Okay, this video is about measuring energy changes. The question asks you to calculate enthalpy change. Other keyword to look for from the beginning is an exothermic reaction. Maximum temperature rise is recorded. So the concept here is how to calculate enthalpy change of an exothermic reaction. An exothermic reaction is a reaction that releases heat. So you have a beaker with some solution. There are some reaction that happening within that solution. The reaction gives out heat to the solution, and that causes an increase in temperature. So one thing to keep in mind is that the solutions, which is mostly water, have gained energy and have an increase in temperature. So the enthalpy of reaction, which denotes as delta H, is actually the opposite of the energy that is gained by the water, which is called Q, divided by the number of mole of the reactant. Well, to calculate the energy that is gained by solution when you have a change in temperature, you use the formula Q equal mc delta T. M here is Q is what we noticed earlier, the energy gained by the solution. M is the mass. C is the specific energy of water. C is specific heat capacity of water. Well, why do we use specific heat capacity of water? Because solution is mostly water. And then delta T, which what we saw earlier is a change in temperature. Delta is a change. Okay, applying this concept to our questions, let's highlight a few key points. We have the mole of the solid. We have the volume of the solution. We have the temperature rise. And we can use section 1 and 2 of the data booklet. So whenever you see temperature rise, you can use the Q equal mc delta T equation. The problem that students usually run into is that, well, what mass do you use? A lot convert the mole into mass, but again, go back to the concept. It's not the reaction that gain energy, is the water, the solution, the surrounding the reaction that gain energy. So really all of these pertaining to water. And our assumption, again looking back at the question, is that all heat released was absorbed by the solution. 1 gram per centimeter cube is the density of water, which we will assume to be true for the solution. So having 80 centimeter cube, that's 80 gram, right? Now the specific heat capacity of water, we could use the data booklet. Your change in temperature, that is 7.5 degrees Celsius. Now one of a common mistake is people sometimes convert this Celsius into Kelvin because the unit for specific heat capacity is in Kelvin. But that is not necessary because the change in Celsius and the change in Kelvin is the same. So this is equal to 2,500 joule. Well, remember that is the answer. They asked us for the answer in kilojoules. I'm going to go ahead and convert this into kilojoules. 2.5 kilojoule. But that's not all. This is only the energy of the water they have gained. We have one more step where we have to look at the enthalpy change. Enthalpy change is negative of the energy gained by the water divided by number of mole. Here, put that in the calculator and you should get negative 160 kilojoule per mole. That's the final answer.